Welcome to The Explainer. Today, we're diving into a massive and honestly incredibly fascinating topic, the intersection of legal compliance and technical data security. If you've ever wondered how global platforms keep data truly secure across borders, or, how to prevent foreign governments from just seizing your assets, well, you're in exactly the right place.
Okay, let's jump right in. Here's our mental map for today. We're going to cover the big data dilemma, residency versus sovereignty, sovereignty by design, blockchain access control, and finally, securing your global legacy.
So, Section 1, the big data dilemma.
Look, we're living in an era where the absolute explosion of big data is putting traditional cloud architectures under immense strain. To really wrap our heads around the scale of this, just look at this number, 80%. A staggering 80% of nations are actively enforcing strict data protection laws by the year 2026. So, managing data across borders, it isn't just a technical headache anymore. It is a massive legal hurdle. And this brings us right to what we call the residency trap. It's this incredibly dangerous assumption that just because your server physically sits inside a specific country, you automatically get that country's legal protection. But thinking physical location guarantees legal safety, that's kind of like thinking parking your car outside a bank vault makes it immune to getting a parking ticket. Relying solely on physical location leaves you totally exposed to international legal overreach.
To actually see this in action, let's look at the University of Saskatchewan's P2 IRC project. This is a massive crop genomics data architecture. What they do is combine these vast data sets from researchers globally using multi-tenant cloud computing, specifically Apache Cassandra. But here's the rub, right? When infrastructure is shared and not completely owned by the users, it opens the door to severe privacy and ownership risks. Basically, globally distributed cloud data leaves you vulnerable.
Moving on to Section 2, residency versus sovereignty.
Now, this right here is the critical conceptual divide of this entire explainer. We really need to separate where your data physically sits from who actually controls it. On one side, we've got data residency. That's your physical latitude and longitude, the actual hardware. On the other side is data sovereignty, your legal authority, your jurisdiction, your actual risk protection. The illusion is thinking server coordinates protect you. The harsh reality? Laws like the U.S. Cloud Act can literally compel a U.S.-based cloud provider to hand over data that's stored on a server over in Europe. Residency is just a technical state. Sovereignty is a legal leash. And because of this mismatch, we run headfirst into what's known as the sovereignty gap. Think of this as the dangerous legal distance between your physical server locations and your legal entity's headquarters. If your servers happen to sit in a jurisdiction with hostile data access laws, your data can get caught up in a massive conflict of laws. And yeah, this can literally freeze your assets. It's a major, major vulnerability. That brings us to Section 3, sovereignty by design. Now, to actually close this gap, we can't just bolt on compliance at the last minute anymore. We need a strategic architectural solution from the ground up, as this really powerful quote from the Actian white paper perfectly captures. From a sovereignty perspective, where the data resides is only one part of the story, right? Location is necessary context, for sure, but it's just not a sufficient safeguard on its own. We need meaningful engineered control. So, to achieve this, we rely on the 3 pillars of sovereignty by design. First up, control. This means establishing absolute, clear decision rights over exactly who uses what data, from where, and for what purposes. Second is enforcement, actually building technical mechanisms across your platforms that apply these rules consistently every single time. And third, proof, having the lineage, the audit trails, and the observability to demonstrate to regulators exactly what happened. The takeaway here? Sovereignty absolutely must be engineered by design, not treated as some afterthought. Let's take a look at how this fundamentally changes our systems. The old way relied heavily on monolithic, centralized platforms and localized storage, which honestly are incredibly rigid. The new way completely flips the script by using federated architectures. By decoupling data, metadata, and compute, you gain this incredible flexibility. You can actually move workloads instead of moving the data itself. In this modern setup, metadata becomes the absolute backbone of sovereignty. It carries all the usage constraints and jurisdictional rules right alongside the data itself to maintain that crucial agility. All right, Section 4, blockchain access control. Let's see how this all builds from theoretical design into practical, rigorous enforcement. Enter Hyperledger Fabric. This is a private, permissioned, distributed ledger. And here's the really brilliant part. Instead of trying to store massive amounts of big data directly on the blockchain itself, the network just acts as a vessel to verify access to a dataset ID. It effectively acts as an auditable access control layer sitting exactly between the users and the secure data stores. To see how this works in practice, let's look at the blockchain identity-based access control, or buyback, ecosystem. In this model, access is granted on a strict user-by-user basis. When someone wants to view an asset, the asset owner uses certificate-signed requests to either approve or reject them right through a smart contract. Meaning, the owner completely retains the sovereign right to grant or revoke this selective access at literally any point, and it creates a permanent, fully auditable trail. Alternatively, we've got the BRBAC model. That's blockchain role-based access control. Instead of individuals, this approach assigns roles to users, and those roles hold the access privileges. So when a user tries to access a dataset, it instantly triggers a smart contract on the blockchain to pull their role and verify their rights. This completely automates the enforcement and proof pillars of sovereignty we talked about earlier. It's totally seamless and, of course, fully auditable. And what's really wild is how flexible and modular this architecture is. Because the smart contracts are handling all the heavy logic, developers can seamlessly integrate everyday tools like HTTP and even SMS. I mean, think about this. An executive sitting at a coffee shop in an airport can securely approve or revoke access privileges to a massive big data set simply by sending a text message to the blockchain. That is just incredible operational freedom. Finally, Section 5, Securing Your Global Legacy. Let's transition from the cool technology into a real, actionable roadmap by looking at the timeline ahead. Right now, we're already facing rapidly evolving Know Your Customer and anti-money laundering mandates. But a major shift happens on October 1st, 2026, when the Financial Data Transparency Act takes full effect. And from 2026 onward, strict standards, like ISO 17442 for legal entity identifiers, become mandatory. This impending regulatory gravity means that mastering data sovereignty, it's absolutely non-negotiable moving forward. So how do you actually prepare for this? Well, Gemba Finance offers a really pragmatic 5-step roadmap. Step 1, audit your data map. You've got to trace every transaction to find that hidden shadow data. Step 2, evaluate the sovereignty gap. Check the actual legal distance between your physical servers and your headquarters. Step 3, implement zero-trust architectures to completely decouple access from physical location. Step 4, leverage banking-as-a-service, or BaaS providers, to handle the heavy lifting of jurisdictional compliance for you. And finally, Step 5, future-proof your systems using the exact sovereignty by design frameworks we just explored. So the crucial point we want to leave you with today is this. As you look at your own systems and your own strategies, you have to ask yourself, is your data merely residing locally, or is it truly sovereign? Are you trapped by physical locations, or have you engineered genuine legal and architectural control? I really hope this explainer has given you a powerful new framework for thinking about data in the modern world. Thank you so much for joining me, and keep exploring.